Damage mechanism is a general term used to describe mechanical or chemical processes that result in equipment damage or material degradation. These can range from corrosion, to cracking, to heat damage, and everything in between. API 571 API-RP 571, titled, Damage Mechanisms Affecting Fixed Equipment in the Refining Industry, extensively covers various damage mechanisms encountered in refineries. This comprehensive guide delves into more than 60 distinct damage mechanisms that may affect process equipment in refining operations. While API 571 is generally specific to the oil refining industry, it provides detailed information on many damage mechanisms that are relevant to petrochemicals, chemicals, power plants, or the oil and gas industry. While API 571 is generally specific to the oil refining industry, it provides detailed information on many damage mechanisms that are relevant to petrochemicals, chemicals, power plants, or the oil and gas industry. It furnishes comprehensive insights into each damage mechanism, encompassing a general overview, materials prone to susceptibility, key influencing factors, recommendations for inspection methods, and strategies for mitigation. API 571, with its wealth of information, finds utility in various industrial activities, including but not limited to identification of existing or future damage and anticipated rates of degradation, development of inspection and monitoring plans, implementation and monitoring of integrity operating windows, development of corrosion control documents, implementation of risk-based inspection programs, conducting fitness for service assessments. API 571 comprehensively addresses every potential damage mechanism encountered within oil refineries and petrochemical plants. Each mechanism is meticulously documented according to the following structure. Name of mechanism. The term commonly used to describe the mechanism. Description of damage. A basic description of the damage mechanism. Affected materials. A list of the materials prone to the damage mechanism. Critical factors. A list of the factors that affect the damage mechanism. Affected units or equipment. A list of the affected equipment or units where the damage mechanism commonly occurs. Appearance or morphology of damage. A description of the damage mechanism with pictures to help with recognition of the damage. Prevention, mitigation. Methods to prevent or mitigate the damage. Inspection and monitoring. Guidance for non-destructive examination and other methods for detecting, monitoring, and determining the severity of damage. Related mechanism. A list of related damage mechanism. References in API 571. The mechanisms are divided into the following sections. Mechanical and metallurgical failure, uniform or localized loss of thickness. High-temperature corrosion, environment-assisted cracking. Refining industry damage mechanisms. Mechanical and metallurgical failure mechanisms. Graphitization, softening, spheroidization, temper embrittlement, strain aging, of embrittlement, sigma phase embrittlement, brittle fracture, creep, stress rupture, thermal fatigue, short-term overheating, stress rupture, steam blanketing, dissimilar metal weld cracking, thermal shock, erosion, corrosion, cavitation, mechanical fatigue, vibration-induced fatigue, refractory degradation, reheat cracking. uniform or localized loss of thickness, galvanic corrosion, atmospheric corrosion, corrosion under insulation, cooling water corrosion, boiler water condensate corrosion, carbon dioxide corrosion, flue gas dew point corrosion, microbiologically induced corrosion, soil corrosion, caustic corrosion, dealloying, graphitic corrosion. High temperature corrosion, oxidation, sulfidation, carburization, decarburization, metal dusting, fuel ash corrosion, nitriding. Environment. Assisted cracking, chloride stress corrosion cracking, corrosion fatigue, caustic stress corrosion cracking, caustic embrittlement, ammonia stress corrosion cracking, liquid metal embrittlement, hydrogen embrittlement. Refining industry damage mechanisms. Uniform or localized loss in thickness phenomena. Amine corrosion. Ammonium bisulfide corrosion. Alkaline sour water. Ammonium chloride corrosion. Hydrochloric acid corrosion. High-temp hydrogen. Hydrogen sulfide corrosion. Hydrofluoric acid corrosion. Naphthenic acid corrosion. Phenol, carbonic acid, corrosion. Phosphoric acid corrosion. Sour water corrosion. Sulfuric acid corrosion. Environment-assisted cracking. Polythionic acid stress corrosion cracking. Amine stress corrosion cracking. Wet hydrogen sulfide damage. Hydrogen stress cracking. Carbonate stress corrosion cracking. Other mechanisms. High-temperature hydrogen attack. Titanium hydriding. By recognizing the specific types of damage that are likely to occur under different conditions, they can develop appropriate strategies to prevent or mitigate damage and ensure severe consequences such as loss of life, environmental damage, and significant financial losses to achieve the longevity and safety of materials and structures. The American Petroleum Institute regulates how damage mechanisms should be addressed. Thank you very much for watching the video. You may consider to subscribe, like, sharing or pressing bell icon for this video, if it is worth doing. Explore our YouTube channel, PetroCelt, for captivating videos covering science, engineering, technology, and energy topics. The primary aim of launching this YouTube channel is to facilitate the exchange and dissemination of knowledge and experiences among professionals and amateur